Hi, everyone. My name is Chris Mattia. My call sign is W6AH. And tonight I'm going to be talking about solar and emergency power, solar and battery power, if you will, for Emcomm. And what we're going to do is we're going to talk about, let me move myself down into the corner so that you can see the rest of the slides a little bit. So what we're going to be talking about is an activity that happened during the 2019 Baker to Vegas race. And I was part of the medical radio network support team. And at every one of the stages along the race, we set up comms across about 150 miles of desert. And it runs from Baker, California, all the way to Las Vegas. And at each of the different stations, we set up these medical radio kits, if you will. These are our commercial radios. They've got an integrated mag mount antenna, an external speaker, and a 12-volt aux port on them. And we would have them at the medical stations, and we backhauled these both to the medical base and all the way back to medical dispatch, all the way back in Las Vegas. And then we used ham radio to back up all of those communications. And then at every single one of the stages, there's oftentimes ham teams that are doing the communications just within an individual stage. But as part of the medical radio network, we set up comms across the entire race. So this was my first race. I'm actually a pretty new ham. A couple of weeks ago was my anniversary of just getting my technician license back in 2018 after the Thomas Fire rolled through my hometown of Ventura, California. And I realized it was the ham radio operators who knew what was going on. And I decided to get involved at that point. So when I showed up on station with any kind of Emcomm setup, you always want to assess the situation. You want to identify and prioritize and resolve any issues that you may have. So there was this immediate need when I showed up in the morning to set up the medical station to get the MRK radio powered up and get the medics so they could check in both with MedBase and with dispatch all the way back in Las Vegas. And at this point, we're about 100 miles from Las Vegas for the station that I was operating at. And then we needed to sustain that radio for the full duration of time that particular stage was expected to be operating for the day. So when the last running team was expected to pass through, that was our off time for that particular station. So for stage 7 that this story is about, we were expecting to have to run and be operable for 15 hours. So that was our goal. That was the parameters that we had to work with there. So when we got there, we realized that the medic's vehicle, these were all planned to have the 12-volt aux plug plugged into the medic's vehicle, and we were supposed to just run off the medic's battery in their vehicle. Well, this medic didn't have a 12-volt aux port in their vehicle, and they couldn't run the radio. So we had to come up with some additional ways to be able to power this. And of course, we ran through a couple of the options, like, well, we could move another vehicle in that had a 12-volt aux port. Well, when we were getting set up in the morning, there were no other vehicles that we could move in because the medic area was a restricted area. We couldn't get another vehicle in close enough. So that turned out to not be an option. It was the easy option to make a switch initially, but we weren't able to go with that. Next, we could have rolled in certainly a generator, something running AC inverter to get 12 volt over the aux port, and that would have been great and all, but I mentioned I was a new ham. I didn't have a generator. I didn't have anything to be able to plug that in with, and there was not one available at the stage when we had to get operational first thing in the morning. All right, so battery power sounds like a plan. So I've been doing a lot of work on batteries. So, and I should mention, for the past 12 years, I've lived on a boat in the Ventura Harbor. I lived on a sailboat. So I've been living on 12 volts for quite a few years. So I'm going to divide the world of batteries into two basic groupings. And these are just very broad groupings. And remember, everything we're talking about tonight is just for Emcomm. We're not talking about overall solar, overall battery usage and so forth. So we're just going to talk about the typical things that we would use for Emcomm batteries. So if we think about traditional batteries, we're talking about your lead acid or your flooded batteries. You may refer to them as your AGM or your absorbed glass mat batteries, or maybe your gel cell batteries. So these are kind of your deep cell, maybe marine batteries, your traditional lead acids, the stuff that's coming out of your cars, motorcycle batteries, those sorts of things. That's what we're going to toss and just lump into the category of traditional batteries for the purposes of this talk. On the side of modern batteries, we're talking about things like lithium ion batteries, or say lithium iron phosphate batteries. And so those are the two categories. There's obviously lots of other types of batteries out there in the world. There's a bunch of other different battery technologies, but for purposes of Emcomm, these are the most common ones that most of us are using, most of us are operating with. So this is what we're going to limit our world down to tonight for the purpose of this. So let's start with our traditional 12-volt batteries that we just lumped in. And let's talk about some of the advantages and disadvantages of this particular battery technology, of what you may want to use and not. So on the advantages side, these things have a lot of capacity. There's a lot of charge that's packed into these. Marine batteries are just incredible batteries. They hold an enormous high density of power in them. However, they're pretty heavy. They're relatively inexpensive. You can pick these things up pretty much at any big box store, auto parts store, marine supply store, West Marine, Boat Bath and Beyond, whatever you want to call them. You can pick these things up pretty much anywhere.
Sorry, I couldn't hear what you said.
Thank you, Siri. So there's also deep cycle models that are available, and deep cycle models you really want to think about with your ham radio gear. You think of like a traditional, like a battery that's coming out of your vehicle. That's a starting battery usually, and so it's designed to crank out a lot of amps really fast to get your vehicle up and running. And it does that by having these really thin lead plates inside that have a lot of surface area, so it can deliver a lot of charge really fast. Your deep cycle batteries are like your marine batteries, those AGMs and your some of those batteries. Those you find in the marine industry, and those have these really thick, heavy plates. They're designed to be discharged to really low levels and not damage the battery. If you've ever had, and I know none of you have ever had this happen to you, if you left something on in your vehicle and your battery goes dead and then you have to charge it up, after that first time of you get that really deep charge, or maybe it happens once or twice, that battery is never quite the same again. It doesn't end up having a really long life after that, because that starting battery, those plates are really thin and they can build up a lot of lead oxide, and they can make it so that they don't actually hold a charge. They don't work as well. So deep cycle batteries, if you're going to do something for ham radio, they're a better choice. Disadvantage, these things are heavy. I mean, they don't call them lead mines for nothing. If you've ever been to an event where you've had to drag one of these things any amount of distance, you got to have your hand truck or be able to pull the vehicle right up to where you're going, because these things are really crazy heavy. They will break your back. And if you're in an Emcomm situation where, let's say in the Los Angeles area, we have a big major earthquake and you have to hike into a location because all the roads are down, you're not going to be able to carry one of these batteries very much of a distance. The other thing is the discharge curve, and I'm going to come back to discharge curve in just a minute, but hold that in your mind as a disadvantage on these traditional 12-volt batteries. If we think about the modern batteries, here we're thinking of things like the lithium ion batteries. These are the batteries that ship in pretty much every modern HT that you're going to get on the market. It's this lithium ion battery that's kind of like already attached into the back. They work pretty good, but you don't usually find these in very large capacity levels. What you do find are these lithium iron phosphates. This is kind of the more modern, newer battery technology, and these are really great. They're really small. So this is a 12 amp hour battery. It's pretty light. It's easy to carry. All kinds of different advantages to these. So this is what we're going to be talking about. And if you hear me mix up some words in here, I may refer to these as lithium iron phosphate. I may refer them as LiFo, Li for lithium, Fe for iron, PO4 for phosphate, or just simply LFP. kind of tend to run through all of them. The brand that I tend to use mostly is Biono, but there's a lot of brands out there that support these. So let's go to the next one. Let's talk about the advantages and disadvantages of your modern 12-volt battery. So on the advantage side, extremely high energy density, 12 amp hours in this little teeny tiny thing that weighs hardly anything, just a couple of pounds, whereas the same size battery as a lead acid is probably going to weigh closer to 20 pounds, whereas this is like 3 to 5 pounds. Much smaller, much easier on your back. They're lightweight, compact size, as you can see, and they have a high number of charge cycles. Now, really about 2,000 charge cycles is what most of the manufacturers are claiming, and that's really important. So as somebody who's living on a boat for a long period of time, your house batteries don't tend to last terribly long, because with those deep discharges and recharges, each one of those is a charge cycle. These lithium iron phosphate batteries have a good number of charge cycles, so you can discharge them, you can use them a lot of times, which really kind of drives the price down on them overall. They have a nearly flat discharge curve. There's a discharge curve again. We're going to come back to that in just a second. And they have connectors suitable for Emcomm. So on the batteries themselves, they already have power poles connected. And so you should be power poling everything in Emcomm to make all of your gear interact with power poles. And these come, for the most part, from the manufacturers already wired up for that. Disadvantage side, high initial cost. There's no way around that. They're more expensive. If you're just looking at dollar for dollar when you're making your purchase, then the lithium iron phosphate batteries are definitely more expensive than your traditional batteries. However, when you take into account the high number of charge cycles and the length of the battery and this discharge curve thing that we're going to talk about next, suddenly it's not actually that expensive of an investment. So this is your typical discharge curve. So as on the y-axis here, we've got our battery voltage, and on the x-axis, I guess I got to point that way. On the x-axis, you have the percentage of discharge of the battery. So for your traditional batteries, your lead acids or so forth, it's pretty much a linear relationship. As you discharge the battery, the voltage steadily drops. Now, on the sailboat, I would know when it was time to charge up the batteries, because the lights in the cabin would just start to dim down a little bit. And I'm like, okay, the voltage has dropped down. I could look over at the little meter on the wall and see, all right, the voltage has dropped down. Let me turn the charger back on, boost them back up. And the lights would come back up and it's nice and bright again. With a lithium iron phosphate battery, the lithium technology, they have this flat discharge curve. During most of the life of the discharge of the battery, the voltage remains almost constant, and then it has this real sharp drop off at the very end. So what does this mean for ham radio operators? Well, this means is right around, depending on the battery, we'll call it 12 volts, but it's, for a lot of it's 11 and a half. It might be something somewhere in that range. Once you reach a certain threshold of voltage, your radio is not going to work. It will not have enough power to continue to operate. So once your curve drops below that line, you're done. You're finished. So it doesn't matter how many amp hours you have in your battery. Once your voltage drops, you're done. So for a lead acid battery, once you cross that line, let's say it's 12 volts, you're only at about 40-50% discharge. The battery is done. You've gotten all of the power out that's usable power. Now, there are things that you can add to like boost the voltage up in order to get it and keep operating. That's going to further discharge your battery and have a more impact on the life of the battery as well if you do that. But if you look at the lithium iron phosphate batteries, you're getting in right around 90% of the power that's stored inside of that battery. You're getting it out as usable energy that you could use to operate. And that means you can stay on the air longer. And for Emcomm, this is key. So when you put all of this stuff together, if you're building yourself a go box, this is my go box that I built. It's just like a little $12 plastic ammo can. I've got my Kenwood D710G in there. I've got a 30 amp hour Biono battery. This is a lithium iron phosphate battery. They weigh about 7.5 pounds for 30 amp hours. And then I've got all of the wiring in to get the power and all the connectors up to the top of the box. So if you're building a Go box from scratch, certainly consider using the lithium iron phosphate batteries as the battery technology that you implement inside of the box. So the next problem that you run into when you're thinking about running your radio off of a battery is, how do you make the connection? And I already kind of gave this one away. You need a collection of power adapters, and I like to say power pole everything. And when I say power pole everything, I mean power pole everything. I mean, I have a little kit here. Let me just bring the kit here up on screen real quick. So I've got a little kit that I have all of these cables and connectors in, and this is what I typically would carry with me in my Go kit. You can see that every single one of the wires on here has power poles on them. I've got, some big alligator clips if I need to clip into a big battery, or some ring terminals for connecting onto it, and maybe another power supply or something. Power poles that have just bare wires on the other end in case you need to build something. You're already halfway there. You're prepared. Extension cables, it's a 15-foot cable that's just got power poles on both ends that I can use to extend out maybe on my solar panels to another location. Or hey, if I need another shorter cable, I can just clip that cable, crimp new ends on it, and we're good to go. We've got two cables. Power inverter, 12-volt power inverter. It's got ring terminals on the ring posts on the back, so you can just connect the ring terminals on there. Now you can run your laptop if you're doing, say, WinLink for communications or so forth. You've got backup power you can use for that. There's connectors on here for different solar panels. The next one over here is a little Y connector. That's just two power poles in one direction, one power pole in the other direction. Say I don't have a splitter or something, I can just use that to connect two sources off of my 12 volts. You don't have to buy all of this stuff either. So my 12 volt plug and 12 volt socket connector, I bought those on Amazon for I think like $3, and then just took the backs of them off, wired on little short leads on them, crimped on power poles, and you've got a 12 volt plug that if you need to draw power off of a vehicle, you can do that. And the 12 volt socket you can use to adapt to any 12 volt socket adapter. So over on the far side, I've got a little USB charger, so you can keep your cell phone or your tablet up and running. You can just plug that right into your battery, and it'll all just work. For your radios, go ahead and clip the leads right off the back of your radio, because most of the radios come with some kind of custom connector that's on the back. This is for my ICOM 7300. And just crimp power poles on it. Then, of course, you always want to have your fuses right up next to. So take your fuses, your inline fuses, put power poles on either side. Now you can go your radio. Oh, I need fuses. Great. I'll plug my fuses into that and then plug that into the battery, or, whatever gear you need. Things like rig runners are really nice for being able to split out connections to have other devices that are running. Barrel connectors if you need to have some devices. Basically, power pole everything is the key, and it all fits in a little tiny bag. I think all of these cables together probably cost me $30 or something by the time I've just built them all. If you buy them all separately, if you've got that kind of money to be able to buy all these, many of these can run like $20-30 or more for some of these adapters if you buy them commercially. So that brings us to the thought of, how do you make them? Well, just go ahead and buy a really good crimper, learn how to crimp them. The components are not very expensive. There's tons of videos out on YouTube to watch and learn how to make them. You can reach out to me. I'll walk you through how to do them. It's not very difficult to create. So let's see. So let's go to the next one. All right. So we've got our station up and running. It's ready to go. At this point, we've got the station on battery power. We were able to plug it in. We have the connectors to make all the little jumpers that we need, and our medic was able to check in. Now, this whole process took maybe 5 minutes. I mean, it really took hardly any time at all because we just come in, we assess the situation. All right, we've got to find other power. We've got the battery on hand. I happen to have a spare one, plugged it in, made the connections. We got her online. Now we have to figure out how long are we going to be able to run this particular radio on this particular battery. Now, the battery that I deployed is a 30 amp hour Biono battery. And so now we need to figure out what's the duty cycle. How often are we likely to be transmitting? We know for most of the medic stations, they roughly are going to run on about a 10% duty cycle throughout the day. They have to check in periodically. But the rest of the time, they're mostly monitoring the radio rather than constantly talking. And as emergency communicators, we're oftentimes listening a lot more than we're speaking. Unless you're net control or unless you're in the middle of a big situation, then you're transmitting a lot. But that's the general thing that we're looking at now. So what I would encourage you to do is to start to think in terms of amp hours. And this is a concept from sailing and living aboard, that once I knew how many amp hours that were stored in my batteries, and I knew how many amps or milliamps every single device on the boat used, I could start to calculate, if I'm offshore, how often it is that I need to recharge the batteries and so forth. And so it ends up being a really nice way to do this. So let's run through a little exercise here. Let's start off thinking about the battery that you've got. So the battery you have, a lot of them will all say, okay, this battery has got 12 amp hours, or this battery has 30 amp hours in it. It'll also tell you the number of watts that are there. I don't like to think of these in terms of watts because watts can tend to get a little bit confusing simply because, well, what radio are you using? Well, I'm using my 5-watt HT, or I'm using my 100-watt this rig, or I'm transmitting at 50 watts of that. Well, how does that translate into how much power is actually being drawn? You got to think about the amps that are coming out. So if you think about these in terms of amp hours, if your battery holds 30 amp hours and your radio draws 1 amp, then how long can you run that radio for? Well, 30 divided by 1, you run it for about 30 hours, just kind of ballpark there. Let's do another example. We got our 30 amp hour battery. Our radio is drawing 2 amps. We divide 30 by 2. We can run that radio for about 15 hours. This is pretty typical for the receive on a lot of our mobile rigs, is about how long we could technically listen using a battery like this. Now, as we start increasing that, our 30 amp hour battery, maybe we're drawing 10 amps of current off of that battery on transmit. That means that 30 amp hour battery is really only going to last us about 3 hours of straight transmitting. Now, you've got to kind of do all of these calculations. How do you figure all of this stuff out? Well, there's 2 basic ways to figure this out. And the first way is to simply open up your user manual for your radio. So this is the user manual page for my Kenwood D710G. You all may have this same radio, and you'll find somewhere in your manual, you'll see that there's ratings for transmit and there's ratings for the current drain on receive. And there'll even be differences oftentimes in the band that you're transmitting on. So say VHF, if you're transmitting on high power, that would be a 50-watt transmitting, then it's typically going to be drawing about 13 amps on both VHF and UHF. Mid power, you're looking at drawing about 4 amps or 6.5 amps at mid power. That is a huge difference in power for how much you're draining out of your battery. So if you do not need high power to get your message out, and you can get that message out on, say, mid power or low power, you can conserve the power that's inside of your battery a whole lot more. On the receive side, this radio is going to typically receive, it's going to draw about 1.2 amps during its receive cycle. So going in and looking through your manual to see roughly how much your radio is drawing can get you a pretty good idea in the ballpark to figure out about how long you could operate on a particular with a particular battery for that radio. The better method, though, is to do some kind of inline metering. Now, an inline metering here, you would plug this where on the source side, on this side, you would plug that onto the battery. And then on the load side, you would plug in your radio, or maybe you've got a rig runner where you've got a couple of other different devices. So this would go inline right from the battery directly for everything else in the load that's going to be calculated out. And what it's going to do at the top number, it's going to show you what your instantaneous current draw is, how many amps are currently being drawn out at this time. It'll show you the voltage, it'll show the wattage, the screen will actually rotate through a couple of these. But the lower left periodically will show up and it'll show you how many amp hours of power have passed through this device. So think of this kind of like your gas gauge. So if this is the one here, 5.206 amp hours, and I know I'm working off of a fully charged 12 amp hour battery, that means it's really easy. I've got a little less than 7 amp hours still left in the battery, and I can know about how long I still have to be able to calculate, to be able to operate at that level. And if I drop the power down, I know, oh, I can operate a little bit longer. These are really great. They've got, this one's by PowerWorks. You can find them for really pretty cheap on Amazon and eBay and other places. This is the one that I happen to have. It works really well for being able to keep an eye on how much power you're actually drawing out of your entire rig, because it's not just your radio, it's anything else that you're running. So how long will the MRK radio run? Well, these radios typically draw about 4 amps on receive. These are commercial radios, remember. And the power setting that we had to have them on, because as part of the medical network, we had to keep them up on high power, they were drawing 20 amps on transmit. So at our 10% duty cycle, we could guess that this battery was going to last me roughly about 7 hours just at the check-in. That's not if an emergency actually happened and suddenly the medic needs to be talking all the time. So it's not a big buffer for having to keep this station up and running at that point. So we needed to come up with some other solutions to keep this station on the air. And that's what the rest of this talk is about. So when you start thinking about—
Chris, can we break in here for just a second and
Sure.
bring on Tom? He has an important point to make. Tom, you want to go ahead? Tom, go ahead. W3TDH, Tom, go ahead. Make your point, please.
Yes, sir. With all the power strips that have individual fusing on the outputs, they are unlike any other electrical arrangement that we use any place else. The protection is not wedded to the wire.
Correct.
So if you want to actually have the wire you're going to use protected, your fuses go in the wires, and you put the maximum safe outlet fuse on each and every outlet, and all of your wires are fused at their actual ampacity. Under the stress of an emergency, you will eventually plug the 2 amp cable into the 30 amp outlet. It's inevitable. And you'll not see any electrician, I did it for 45 years, or any automotive wireman or any sailing technician, any of those people, you will not see them wed the ampacity to a plug-in outlet. They don't do that.
Right. So, and that's to your point, that's exactly why you do things like this. You can take your inline fuses that you have, put your power poles on either end of it. You can use that rig runner as power distribution, plug this into your rig runner, and then that can go into whatever your device, the rest of the line into it. So you've got the appropriate size fuses for your rig, whatever that happens to be coming off of there. That's a really good point. Thank you very much for that. So your options here are really, you can reduce power, so you can lengthen out the line. In this situation, that was not an option for us. We were not going to be able to do that. You could have additional backup batteries. I only had this one battery with me, so we're going to need to augment that in some way. And that's the other option. You can augment that power. But what it's really buying you with this solution right here is it's buying you enough time to think about the next step. So the first problem was get the unit on the air. Then you want to keep the unit on the air. How you solve those problems is going to be entirely dependent on the resources that you have available, what you can get brought in. And you've got some gauges for how long you may need or how quickly you may need to solve that next problem. So it's just a series of problems that we're trying to solve. So let's talk about augmenting your battery power with some other type of power generation in order to keep your station on the air. Now, in an ideal world, we would all be able to carry roughly 2 to 3 days worth of Emcomm power on our back as we're deploying into a situation. So we've got enough power. That's just not feasible for most of us to carry the weight of the batteries or other some kind of generation. You could bring us a fossil fuel generator to be able to do that. But if you're having to hike into a location, that may also not be an option. So your next option is to generate enough power to augment your Emcomm power needs in order to keep your station on the air. And you've got a couple of options here. And this is really going to depend on your particular situation, where in the country you're operating at, what the particular emergency is. You may be able to go to a fossil fuel generator. You might be able to use solar, wind, hydro. There's lots of options. Here in Southern California, during normal situations, like say in an earthquake, in normal situations, we have plenty of solar power, plenty of solar radiation available. So having solar panels in our kits, if our deployment kit is primarily designed around supporting, say, our served agency of a hospital during an earthquake, solar panels may be a great option. However, in a forest fire situation, solar panels are not going to do a whole lot for you, simply because the sky turns black and there's not a lot of solar radiation coming down to you at that point. So you really have to think about the exact situation of how you're going to supplement your power. So for this particular situation, though, we were out in the desert. We had gobs of sunshine available to us, so we use solar. It worked really well. So let's talk about the types of solar panels that are most common for Emcomm. And there are more types out there and more different situations. We're not talking about a shack that's set up somewhere that's off grid. We're just talking about portable power at this point. So the first type of panel is going to be some type of monocrystalline panel. Now, monocrystalline panels, these are the most efficient in general. They come with a pretty high cost usually. Each of the individual little cells here, the way that I've got them just sketched out, would be grown as an individual silicon crystal. And so you would then have these crystals would be wired together in an array. You can oftentimes tell these panels just from glancing at them. And this is not a, cut and dry as it could be, because there's lots of manufacturers that do weird stuff to make you think that they're better panels than they are. For the most part, your monocrystalline panels appear black in color in the full sun. They have this like really dark black color to them. There are some who tint their panels to do that, to make you think they're better quality, but that's kind of a quick glance at them. They oftentimes have these diamond pattern interconnects between the different crystals. Again, not 100%, but it's a quick kind of tell for them. So for the buck, these are probably the best ones that most of us are going to go with. However, they're oftentimes a little bit bigger. They're a little bit heavier than some of your other panels. The next type of panel, the big broad category, are your polycrystalline. Now, these panels oftentimes you can tell just from looking at them. If you get up close to them, you'll see that the crystals themselves are lots of little crystals that have all been wafered together. And so if you look at it closely, it's got this weird pattern that's on them. If you look at a polycrystalline panel from a little bit of a distance, you can usually pick them out because they're usually kind of blue in color, and they usually have kind of a sheen radiance to them, and that's that picking up of the different crystals that are laid out together that you're seeing. These are dirt cheap. You'll find these at your big box stores. You'll find them at places. If you find solar panels, they're $100 for 400-watt panels. They're probably polycrystalline panels. They're usually pretty big. They're not very efficient. The actual technology themselves are not terribly efficient. And so if you're talking about Emcomm situations, you're going to have a lower energy density with your polycrystalline panels. So you need bigger panels to carry into your location in order to get the same amount of power output as things like your monocrystalline panels. The third type that are most commonly used in Emcomm are your thin film panels. Now, when I say thin film, I mean things like the power film solar panels. This is a 60-watt panel, and it's really small. It fits in your bag, and you're able to carry the thing to the location that you're needing to set up and operate. They are more expensive. They are a little bit less, they are less efficient than the other two if you're looking at size per watt or size per amp that they're actually putting out. But that's not as big of a deal with these because they fold, and they fold up really small. So you don't have to worry so much. So I'll show you my 60-watt monocrystalline panels, and we can compare them to the 60-watt thin film panel for size purposes. So these are by Biono. These are 60-watt panels. They've got this nice aluminum frame. They fold down. You can see the little diamond pattern. You can see that they have that kind of black, dark, deep color to them. They've got a nice rigid frame with an integrated stand, so you can rotate them, so you can keep the sun always kind of like pointed in the panel to optimize their performance. But those, if you're going to hike somewhere, are not the same as hiking with something like this. Here's another example of these are also monocrystalline panels. These are also by Biono. This is two panels. These are both 28-watt panels, and they do fold up pretty small and come back. They're kind of like the size of a 3-ring binder, a little bit heavier, not quite as efficient, but they've got grommets on them, so you can like strap them to a pack. You can hang them up in different configurations. They work pretty good, and these are pretty reasonably priced. This is what the power film solar panel looks like, and you literally just throw it out on the ground. It does have grommets in the corner, so you can stake it down if you're in a high wind situation. You could also hang it up. You could put it up on, like, say, if you're operating with an easy up at your station, or you're operating with a shelter, you need to hang it up or drape it over your vehicle. They're really nice for being able to just throw out and start collecting power. So this is my portable solar power kit that I oftentimes carry with me for most of the time. I've got my 60-watt panels here. I've got a 12 amp hour Biono battery, and I've got my solar charge controller that we're going to talk about here in just a minute. But that's a complete solar charging system right there. And you would say swap out the battery for maybe a higher power battery if you needed to maybe to operate longer for something like that, or you would have one on charge and so forth. So let's talk about series versus parallel in the panels themselves, not in how you wire your panels together, but I'm talking about the manufacturing of the panels themselves. And this is something that we want to pay attention to when you're doing when you're looking into buying and investing in solar panels. So solar panels themselves, and I'm talking about the individual cells here, how they're wired together, by and large are either wired mostly in series or mostly in parallel. And of course, they're all, kind of merged a little bit, but they're usually predominantly one or they're predominantly the other. So solar panels that are wired predominantly in series, they add their voltage together in order to get the voltage up to a level that they're going to deliver out to the device. Solar panels that are wired largely in parallel, they're going to add their amps together to increase the amperage, the power output that's going out, but it oftentimes comes with a little bit lower voltage that's going along with that. So that's the kind of balance that we're looking at. And why is that important for Emcomm? Well, it's important because of shade. Now, living on a boat, as I mentioned, when we would operate on our solar panels that were on board, if a line were to go over one of the panels, a rope on the boat, if a line goes over one of the panels and it shades it out, that panel drops its power output enormously. And here's why. So a lot of panels that are wired predominantly in series, excuse me, they're going to be cranking out their power, and all that power is kind of they're increasing their voltage there. Panels that are wired largely in parallel, they're going to increase their amperage of pushing out more amps that are going out with the power that's available to them. Now, if you were to shade one cell, just one of these little squares, if you slide that over, look what happens. If you're in a situation where your panels are largely wired in series, the overall output of the panel drops dramatically down to almost an unusable level of power. Whereas panels that are wired largely in parallel, those will continue to put power out, and they will of course drop their power at some rate as to the number of cells that are being shaded, but nowhere near as much. And this is where the cost of your panels really comes into play. So these panels here, when I deployed them at the Baker to Vegas race for stage 7, they were cranking in full sun about 4 amps pretty continuously. So they were doing a fantastic job of keeping that battery at float all day long. But I came back later in the afternoon as the sun had continued to shift around, and I found this. I walked over to the panel, to the battery, and I looked, and the panels were only putting out about 1 amp of power. And I thought, what the heck is going on? I walked around the other side and saw that just the corner of the panel was being shaded, and just that one corner was enough to completely drop the power output of those panels down to almost an unusable level. As I just moved it out just a little bit further, so the panels got back into full sun, bam, they came right back up to almost a full 4 amps of output. And that was a huge lesson learned there for Emcomm Power. Now, the Power Film solar panels, I love these things because they are wired predominantly in parallel for the panels themselves. So if you cover over one of the cells, if you're in a shaded area, you can actually fold these over and cut them down. They do reduce power, but it's not you're losing the full power out of the array. So these have become my go-to panels for Emcomm use at this point, for the portability and for that ability for them to be shade tolerant. You can get panels. You want to make sure that your panels are matched if you're going to link them together. Many panels that are sold by the same manufacturers will oftentimes have the ability to link them together. So if you link them together, then you can, depending on how you wire them, you can either increase usually you're increasing their amperage, so you can get a little more amps out of them. So these are 2 28-watt panels, and when you put them together, instead of putting out roughly a little less than 2 amps, they're roughly putting out pretty close to 4 amps, around 3.8 or so. And so it makes a nice small compact package for being able to do that. So the last component of your solar charging system that you absolutely must have is a solar charge controller. You can't just take your solar panels and plug them into your battery, because if you do, bad things will happen. So let's talk about solar charge controllers. They generally look something like this. So solar charge controllers, just the basics for Emcomm. So they are always required. Just don't plug your solar panels directly into your battery. They regulate the power that's being generated by the solar panels, and they manage the delivery of that power to your battery. And they do it based on the battery technology that you're charging. So a lot of times these solar charge controllers will have either controls on them, they'll have little dip switches or something like that to go in and set what type of battery technology you're using. So your solar panels, if they're charging, say, a lead acid battery, they would deliver the voltage in a particular way. They would deliver the power in a particular way. If you're charging, say, lithium iron phosphate batteries, they would deliver in a particular way, and so forth. They also prevent power from flowing out of the battery and back into the solar panels. Pretty much every single one on the market has a blocking diode in it so that the power can only flow out of the solar panels and into your battery. Solar panels are just as happy to just radiate your electricity that's stored in your battery back out as heat all day long or all night long, if that's the case, if you don't have a blocking diode on them. And pretty much all your solar charge controllers have that. So that's kind of the basics of it. Now we start thinking about Emcomm. You need a solar charge controller that's designed for ham radio. Don't just get the cheapo off the shelf, whatever solar charge controller at the big box store, because it's not going to be RF quiet. It's going to be really noisy. You're going to see hash all over the bands. And a lot of that is oftentimes coming from the solar charge controller that's using cheap electronics inside of there. You need to make sure that your solar charge controller can handle the expected load of your radio equipment that you're expecting to use. Not all solar charge controllers are created equal. Most of them have these little ports on them, and usually they're power poles. And a lot of times they'll have ports on them where you can plug your radio, where you can plug the load directly into the solar charge controller. Not all are equal. Some can handle loads such as this one, the Power Mini by Buddy Pole. These can handle 30 amps out of both of their load ports, whereas others will only handle 15 amps out, which if you're using, say, a 100-watt radio because you're doing HF communications, suddenly bad things are going to start happening where your radio is going to be very unhappy that it's not able to draw all the power that it needs if your radio does that. You also need to make sure that your solar charge controller can handle the load, the voltage coming from your panels. So just because you get that great upgrade because the solar company just sent you those 300-watt panels or those 500-watt panels because you got them on a special or whatever, you need to make sure that your solar charge controller can handle the voltage that's coming out of those panels and be able to operate safely with those. For the most part, as long as you're staying under about 150-watt panels, most of the solar charge controllers that are designed for ham radio can handle those. You're generally pretty safe, but definitely check the documentation from your manufacturer that you're doing your due diligence to find. And these come in basically two types, your solar charge controls. They come in PWM and they come in MPPT. Now, what the heck are those alphabet soups there? So let's compare and contrast at a very high level. PWM, or pulse width modulated solar charge controllers, to MPPT, or maximum point tracking, maximum power point tracking. It has nothing to do with PowerPoint. It's anyway. So PWM, these are usually your cheaper ones that you have. They operate by simply switching and allowing a predetermined average current to flow into the battery. And they usually have switches or some controls on them so you can set the battery technology. And that usually is what's setting the rates and the all of the currents that it's going to be delivering at some set rate. It's just going to keep delivering that amount of current each time. And it works by simply rapidly switching on, just like a light switch, turning on and off the solar panels going into the boat and it's going into the battery, and it's just letting that power go in for every cycle. MPPT, on the other hand, these are definitely more expensive when you find them. They're much higher efficiency because they've got one of them fancy computer and things inside of them, and it's intelligently managing the output that's coming from the solar panels, and it's figuring out the optimized charging cycle that needs to happen inside of the battery, and it uses fancy math to do that and computer things to drive all of that. And they are really ideal for long-term operation. They're great. There's absolutely there's no doubt about it. These are fantastic. But the question is, PWM versus MPPT. Does it really matter for Emcomm? Well, think about the situation that you're going to be in with most Emcomm deployments. We're getting our systems up and running. We're getting comms up and running quickly. We're oftentimes operating for maybe short periods of time. There are certainly situations where we may be doing operations for long periods of time. But by and large, we're looking at kind of short-term operations that we're working with. So does it really matter? For most situations, not really. If you're going to make a trade-off in costs in one place or another, and you're really up against the wall, and which one do you get? Do I go with the more expensive MPPT? Do you go with the PWM? For Emcomm use, the PWM will oftentimes get the job done for you. Now, if you're going to be setting up for a long period of time, or you're doing some more off-grid work, then yeah, absolutely get the MPPT one. It's worth the investment to be able to do that. So let's talk about connecting your solar charge controller. Let's talk about connecting your solar system. So we're going to start with that solar charge controller, and we're going to plug your battery in first, because what happens is when you plug the battery in first, that is what's powering almost all of these, the solar charge controller. So it gets the brains booted up, it's ready to go, it's ready to start receiving and doing its solar charge controlling thing. The second thing you're going to do is you're going to plug in your solar panels, and so charge is going to start flowing into the solar charge controller, regardless if it's MPPT or PWM. It's going to do its thing. It's going to start charging the battery, and it's going to start doing that pretty much instantaneously as soon as the solar panels hit the sunshine. And that's a good point. You don't want to take your solar panels out and set them up and leave them sitting out in the sun, because now you have live wires that are pumping out power sitting there. You want to make sure that you've got everything else in line. Then you pull your panels out, then you open them up, plug them in, and you're good to go to get those working. The third thing that you would plug in would be the load. This is oftentimes your radio, any other equipment that you're plugging in. And for a lot of solar charge controllers, there is a load port on them, and so you can plug that load directly into the solar charge controller. Make sure it's one that's rated to be able to handle the load that you're expecting. Alternatively, many of the batteries out there have 2 leads on them, and so you can plug your solar charge controller into, say, one lead and your radio into the other, or your other load or equipment. If you do that, I would really suggest using one of those inline power meters, so you know how much power is coming out of that line. You're going to have to do those calculations yourself. Most solar charge controllers, this is the one by Biono power. They've got a little LED panel or LCD panel, and they'll tell you what's going on with the charge, and they'll have some data, and they'll show you nice, interesting things on it. Some of them you need to wire up your own leads on. So like this one, I wired in. I chose to put yellow heat shrink, so I would always know, because there is a little icon on there. I don't know if you can see it. My eyes aren't that good. That says the first port there is the sun port, and so I used yellow because it looks like the sun. Green, that's my battery, because the Biono batteries, if I didn't have something up there, it would show you green right there. But they're green, so I know, all right, I plug my battery into that one. And then white, that's the load if I'm going to operate on it. Now, something to note, the Biono solar charge controller, this is a PWM charge controller. This one can only handle, and you would have to double check the documentation, don't quote me on this, but I'm pretty sure this one can only handle a load of 15 amps or lower. It might be a little bit lower than that, but it's about 15 amps. So let's say you're running an ICOM 7300 and you're transmitting on high power, 100 watts, you're trying to get that message out. That radio is not going to be happy operating off the load port on this solar charge controller. So in that case, you would want to plug directly into the battery as opposed to into the load port on this. For things like the Buddy Pole Power Mini that can handle a load of, say, 30 amps out on their 2 load ports on the far side, it handles it just fine. So your LEDs, usually they'll show you like the system voltages for both the power inside of your battery, what your voltage is, and what's the voltage coming in from your solar panels. They'll show you the amps in and out so you can see how much is kind of coming through. A lot of times they'll calculate the net amp hours that are coming in from the solar panels and that are being either pulled out or charging into the battery. This one, there's 2 lines in the middle, and there's the little fat lines with the little horizontal line thing there. That's actually like a volume gauge. It's showing you it's kind of like a gas gauge, how full your battery is. And that's based on set points that you have, and you can control the settings on these things as well. If you look at them, let's do a little quick review. So the first thing you're going to plug in is the battery. It's going to go right into that battery port. Second is going to be your solar panels. And then third, over there on the right-hand side, you would plug your load in. That would be your radio or any other equipment. Here's a couple of examples of some solar field stations for ham radio. So this is actually a mesh node that's on the pole that's kind of directly above me up there. We were shooting a mesh connection about 22 kilometers across the San Fernando Valley. We've got the solar panels set up. There is the 30 amp hour Biono battery, the solar charge controller. We actually have a power inverter in there, and it's running the laptop and the mesh node all at one time to make that connection. Here's a winter field day station that was set up, a little easy up. We just throw those panels out there, and the battery and all of the other gear is all underneath of the canopy. This is the kind of thing you would typically set up for an Emcomm deployment, antenna out a little bit further from there. Here's a field station I set up on the backside of Mount Wilson, and I've got 2 solar systems running here. I've got the larger panels here. These are the 60-watt panels, and underneath of there is one of the solar charge controllers and a battery, and that was just acting as a charging station for me to keep that battery just topped up. You know, I show up on station and I get that battery on charge right away to make sure it's always topped up, ready to be swapped out if need be. On the main primary station, I had the 2 smaller panels wired up together. Those are going into the solar charge controller and the battery and the radio there. This is what it looks like a little bit closer to it. So all this stuff is just kind of set out. It's not, I don't have my stuff all, nice together in a, fancy little go box or rack kit for that. This is a field day station that we had set up. These are a different type of the monocrystalline panels. They come in a lot of different formats. A lot of them now are really thin. They're pretty lightweight. I think these were 100-watt panels that were set up here. Really nice. You can just hang them up on the easy up, and they're just passively pulling in power, depending on how efficient you need to be able to make your solar collection. Ideally, you want to make sure that the panels are always pointed at the sun. And that means you got to oftentimes rotate them around during the day as the sun tracks across the sun. But yeah, they will collect some power as they're just sitting there. There's another station I have set up. I've got the little Biono ones set out there, again, wired up together. And this is where I set up at the marina sometimes, and set up my buddy pole and just operate for a while. Back to the Baker to Vegas race. So this is the night before the race started. We're if you're looking out in that little flat bit of desert over there, that is Baker, California. That's kind of over in that direction. This was one of the stations that we had set up. I just set the panels up. Put the battery underneath of it, solar charge controller on it. It's a really good idea to use the shade that's generated by some of these panels to keep your battery cool, keep your electronics all cool. It's a nice little spot to be able to do that. So what was the result of this? Well, the result was that we got our station online. We got the medic station online running off of the battery. We were able to back that battery up with the solar panels. We just kind of kept checking them all day. We had to keep rotating the panels around to make sure we're getting that optimum charge all day long. But we were successful in keeping that station online. We started the station at about 10 o'clock in the morning. And we took the station offline at about 10 o'clock at night. So it ran for about 12 full hours. We estimated we were going to need to hit 15 mark, but we hit 12, and the last runners passed through. We were released from that station. So it did its job. And that brings us back to one last thing, and that is this picture that we saw earlier. And I mentioned that you can plug the source into your battery and you can plug the load into whatever is drawing your current. Well, in this case, this is actually the morning after the race. And so for the source, this is actually in the room that I was staying in. I had this plugged into the AC charger for the battery, and then the battery is plugged. I guess the battery's over there. The battery is plugged. Which way am I pointing? That way, up there. The battery is, in this case, the load. So after running that MRK radio that, remember, was drawing 4 amps on receive, it was drawing 20 amps on transmit. It operated where the medic was checking in at about a 10% duty cycle for those 12 hours. It was being backed up by the solar panels. They were just 60-watt panels with a 30 amp hour battery. And in the morning, when I completely recharged that battery, it had only drawn down 5.206 amp hours because the battery had been topped up the entire day by those solar panels. And with that, I will say thank you very much for having me here on the RATPAC. I do run their website, wavetalkers.com, and we do a live stream on Sundays at 1 o'clock. And there you go. So thank you very much. We'll take any questions that you guys have. I'll do my best to answer them.
Okay, Barry, you've been watching the chat. You got anything over there first?
Yes, I do. Tom wants to know, since you're a sailor, have you used any of the small wind generators, and might one be used as a backup for solar for smoky or cloudy periods? And how much do they weigh?
Yes, I have used them. Yes, they are effective. They do make portable wind generators. I do not have any of them myself, so I cannot vouch for how actually effective they are. But there's absolutely no reason that they should not be used, especially, and it's something that we've been looking into doing for the Baker to Vegas race, because we oftentimes have a lot of wind out there. Some things to keep in mind with wind generation is that you have a turbine that is actively spinning. So depending on the location that you're at, you need to make sure you've got a safe zone around that, because you have the spinning fans. You also may need to raise them up to a particular level to get into the wind at that point. But there's absolutely no reason they shouldn't work. I do not know of any offhand. I know there's tons in the marine and industry that mount on the backs of boats, but I don't have a portable one to be able to test that. And there are also ones where you can take, if you're in an area where there's streams available to you, there are little small portable generators that you can toss in a stream, and that will rotate and generate power from the flowing water that's going by in the stream. But again, I haven't used those, so I can't speak to their effectiveness.
Okay, thank you. Dan, you got your hand up. You want to take one?
Yeah, I just want to thank Chris for standing up Wave Talkers. I've gotten a lot of great feedback about it, and the little bit I've been able to watch has been really worthwhile. Different battery manufacturers use different battery management systems. Mm-hmm. And in support of your argument that lithium ferrous phosphate is not that expensive, a cycle for lithium ferrous phosphate is rated at fully charged to zero charge. Mm-hmm. Whereas lead acid and AGM based systems, you only get about fully charged to 50% state of charge as a cycle. So if you overcharge your battery a little bit to your anticipated needs, you can go on, well, more or less indefinitely, I guess. I'm not familiar with the smaller ones, but I installed more money's worth of large lithium ferrous phosphate batteries on a large solar array here to power the house. And it comes with a 10,000 cycle guarantee as long as you don't charge them below 32 degrees Fahrenheit.
Yeah.
So I thought I'd bring that up. And those, how do I say it? I have several Go boxes made out of 100 amp hours in series, because I'm driving 50 watt radios here on the other side of the living room and in the truck with the batteries. They make ideal batteries are great filters. They filter current better than any alternator, generator, or solar panel can. So there's a oversizing that kind of stuff pays off, is all I'm trying to say.
Yeah. Now, one thing to definitely keep in mind with your lithium iron phosphate batteries, check with your manufacturer before wiring your batteries in series or parallel. So for instance, the Biono batteries, absolutely none of them are recommended by the manufacturer to wire their batteries together in series, parallel, or so forth. Have separate batteries. So I have two of the 30 amp hour batteries, and I have a 12 amp hour, which is my smaller, more portable one. If I use my, I can use this 12 amp hour battery, and with my solar panels, and I can run my ICOM 705 pretty much until the heat death of the universe. With this configuration, it'll last pretty much forever at that point. But definitely check with your manufacturer before you go ahead and try and wire your batteries together. It's not quite like, so in my boat, the house bank is a whole bunch of 6-volt batteries, big golf cart batteries. It's very similar to running an off-grid kind of setup, and they're all wired up to give me the right voltage that I need and the right number of, my current that I need.
Series parallel.
Yeah, series parallel. And so for Emcomm work though, you're generally, you want to oversize your battery as much as you can. You're definitely right there. I got the 30 amp hour ones because because of the radios that I run, you want to anticipate the needs that you have. And make sure that your battery is sized for your needs. Now, if you're trying to plan for, say, the net control station or the Emcomm group, then you may want to really upsize to much larger batteries or consider different things. But what we're talking about is kind of your average user that's going out to deploy is what I'm thinking with these.
Unfortunately, in Aries, the age of the average user precludes backpacking much of anything. So anything I do is going to have wheels under it one way or the other.
Yeah, absolutely. And that's why I went with these, the 60 watt panels.
Those are great.
These are amazing. These are absolutely amazing. I love these things. I can't say enough nice things about it.
Small battery and an extra one of those is a better weight investment than a larger battery.
Yeah, absolutely.
Yeah, okay. Well, thanks a lot for everything. I really appreciate all you're doing.
Consider when you're sizing your battery, how long you can operate on just the battery without the backup solar, and think about how long it is dark in your area. So if you're in a further northern climb, where your night is a lot longer than some of us say in Southern California, or if you're operating down in the tropics where you're 12 and 12, if you're in a place where you got a longer dark cycle, you may need to have a larger battery bank, and you may need to have larger panels to charge that bank up during the day to optimize your power. So all of this is kind of a calculation that you need to make for your particular situation and what you expect to see.
All right. Well, thank you, Dan, for the question. Barry, how are we doing in the chat area?
Okay, I got a couple from here. Okay, from John, he thinks the Epic Power Gate has a temperature sensor to avoid charging below 32 degrees. In a pinch, would you charge at 30 degrees or 25 degrees?
I live in Southern California now. I used to live on the East Coast where I had to worry about that. I don't have to worry about that so much now, so I haven't paid too much attention in that, and I prefer to sail in warmer climates. So
short answer is no.
Short answer is probably no.
It will destroy the battery. It's not an iffy thing.
Okay. And Charlie has a question. He has a 20 amp hour Biono battery, and it sometimes shuts down when transmitting on 70 centimeters. Have you found this happening?
I have periodically found that happening. So here's a couple of things that you may want to consider. I would ask, what is the radio that you're transmitting on? And does that happen when you're only transmitting on high power? Oftentimes, all of the, specifically the Biono batteries, have an internal, I didn't talk about this, they have an internal BMS or battery management system. It's an actually circuit board that's inside of the battery. And that is managing a lot of the controls, and there's specific set points. So it is possible to get to a point where you trip that battery manager for a variety of different reasons. One of which could be that your battery has just the charge that's in it. You've hit that point in the curve that you're say running on a 50-watt radio that's drawing a lot of current, and the battery can't deliver it at that point. The battery manager can trip at that point in order to protect the battery. There is a way to reset that. All you need to do is plug it in and charge the battery just a little bit. So I'm not going to tell you that you could actually take your solar panels, you could plug them directly in and you can reset that. I am not going to tell you that I actually may have done that at some point to reboot the BMS inside of a battery. I would never, suggest anything like that. But it does work. Or any other battery that can be plugged directly in, or ideally you want to plug your charger in. So one of the things that I do in my vehicle, if I realize I'm operating for a long time, I'll have my AC adapter, and I'll have the power inverter in the vehicle, so I can plug the power inverter in, plug the charger in, and just reboot the battery in there. You could also, I've seen some instances on some batteries where, especially in the 70 centimeter range, if your antenna is really close to the battery, on some frequencies, I've seen one trip before. And so the solution there is drop your power level down again, and that can also handle that for you as well.
Okay, thank you very much. Mary, how you doing? We haven't got your hands up, so
we're good with questions in the chat. A lot of good comments, but all the questions have been answered.
yes, there is a lot of comments in chat. I'll be sure to get that out to everybody when I send out the follow-up. Well, Chris, I really appreciate this. This has been a great presentation. You obviously have some neat toys there for this.
Well, I've been setting up the Wave Talker site to be able to teach ham radio operators how to operate more effectively. So I have been specifically going out, learning a lot of the stuff, and collecting a lot of the technology. And I teach online for a living, so this is the kind of thing that I do anyway. So
cool. Well, really appreciate this. I'm going to send it out there again. Are there any more questions? Either put in the chat or raise your hand. Well, let's open it wide open. Are there any comments out there? Crickets.
Sheila said, please give further presentations. Love the information.
Absolutely. Please join us on Wave Talkers at 1 o'clock on Sundays. We live stream every Sunday. This Sunday, we're going to be talking about, if I could do a little plug for it, we're going to be talking about WinLink. We've been running classes with that. And if you look behind me, I'll move myself out of the corner, down into the corner. This past Sunday's class. Everybody that checked in live during the class via WinLink, and we generate these maps during the class to see where everyone is. And yes, we're going to show you how to be able to do this with WinLink on this Sunday at 1 o'clock. Just go to wavetalkers.com. You can find us. You can also find us on YouTube, Facebook, LinkedIn, all those places. We're on all of those.
They're everywhere. They're everywhere.
Yeah.
Okay.
Doug has his hand up.
Hey, Doug, what's up?
Hey, guys. I've got kind of what you've got set up. I've got a 100-watt or a 30 amp hour battery and a couple of packs. And I did the same thing. I put the I didn't use a Power Mini. I used a different controller, PowerWorks. But I set that one up, plug a solar cell in one side of it, plug and outputs on the other with some fusing and switching. But I used a hard fuse block, similar to what you'd use as a marine fuse block. I will say that having bought a couple of the 100-watt panels and tried to move them around, I'd buy a power film the next time or something very similar, and probably rather than 120-watt one, probably 260s, and chain them together if I needed the extra output. But that's and I'm my back does not like dragging stuff around. I'm kind of like Dan, you know, it's gonna be on wheels or something. So my 2 cents, but thanks, good presentation.
Thank you. Yeah, I have those 60-watt the rigid panels. They work great. They're very efficient. They're really wonderful, but they are a little heavy. They're a little large. I don't have them here in my booth. They're out in the garage. When I'm transporting in my truck, I definitely have those with me all the time. But at this point, I have the 60-watt folded panels. If you get them all from the same manufacturer, you can link them together. A pair of 60s does a really nice job. That generates roughly a 60-watt panel in general is going to put out right around 4 amps in full sun, fully optimized if everything's working correctly. 120-watt panel, when you take 2 of these and you link them together, generally you're going to get 7.5 amps. It's not a direct add. You have some losses in there, but 7 amps is a great amount of power to throw back into your battery to keep that battery up at float. So yeah, I completely agree. Good, it's a good plan.
I'll throw one other thing in is you can buy batteries from a lot of people. Most of mine are Biono, but they absolutely have stood behind their warranty. I've had a couple that over time the casing started to crack and they replaced it with no argument at all.
Yep, likewise. Great. Kevin is the guy. He's a ham. It's a local U.S. company here in Southern California. All of these products that I use, by the way, are all fully American companies. So Power Film Solar are all U.S. based. They're in the Midwest. Somewhere does it say? It doesn't say on it. I don't recall off the top of my head. Buddy Pole is located up in Oregon. They're entirely U.S. based. All their manufacturing. They're a really small family shop. And Biono is located here in Southern California. They're also a local U.S. company that makes all their batteries here in the U.S. as well.
One thing you didn't mention, and I've bought a number of the LED camp lights, 12-volt, like the 4-wheel drive guys use. Some of them with mass, but after the last hurricane, those went in the house. The solar panel went out on the back with a 30-amp-hour battery, and we had good light in the house, but it's all 12-volt. But
yeah,
those 12-volt LED lights do a really good job for a field setup at night. You can run them off the same thing if you get some that don't draw too much current.
I mean, having this equipment to run your radio gear is like the first line of defense. In my house, I have somebody living with me who needs a CPAP. And so when we have the rolling blackouts here for the power shutoffs for the fires, we convert the ham radio battery banks over a spare set in order to be able to run the CPAP. So knowing what you're doing with 12 volts and being able to be flexible to be able to solve problems with it is a really good solution.
That's good. Okay, let's pick up some more hands here. Frank, go ahead. WBAYHD.
Okay, thank you very much. I just want to make a comment on Doug's recommendation for the larger power films. I've had some of the smaller power films. I can't remember what size they are, but they have an integrated lithium cell system in them, which is pretty kind of cool. And they're really small. I put those actually in a backpack and they take up practically no room. A friend of mine and I really kind of scored big time at trying to remember which hamvention it was down here in Dayton, but Power Film was in attendance. They were selling off what they called blems. Couldn't find anything wrong with them, but they had something that they built for Doctors Without Borders to use in, I think it was Africa, not sure. 150 watt foldable power film system that rolled up into the size of about a sleeping bag roll. Okay. Bought those for I think 300 or 350 bucks. He got one, I got one. I should have bought two. The point is though, normally I'm trying to remember what that costs, 1,500 bucks, something like that. It's extraordinarily expensive and it isn't light. Okay, now it rolls up relatively small and you can carry it a pretty good distance. It's not something you want to do a lot of hiking with. I like your approach, Chris, with those smaller 50 and 60 watt panels that you can gang together when you want to, okay, to get a little bit more power. Now, that's another thing with this larger array. Originally, I had a 10 watt Samlex, I think it was, controller on it. That controller did not like that panel at all. It was constantly burping out because it was getting too much current. Yep. I had to buy either a 20 or a 30 amp hour controller. Now the controller and that panel get along pretty well. I'm a little concerned because it is a PWM. I haven't checked out how quiet it is because I use it with an Icom 706, not only on FM, but also on sideband. But the power film stuff is fabulous. It's manufactured. You can beat the snot out of it. It's been in the rain. It's been in the mud. It doesn't care. The connectors are very well made. Made in the US. It's fabulous stuff. But I would not recommend for a portable operation the larger power film packs because they are bulky relative to that little one that Dan's got there on screen. And or I'm sorry, Chris has there on screen, and they are kind of heavy. You can move them, but you're not going to be walking 5-10 miles with them.
So the power film panels, a lot of times I think most all of them, they come with this. It's a watertight connector, and their extension cables are all they click in. So that it works really well. The panels that are their rollable panels are weatherproof panels. You can leave those out. This one is not a weatherproof panel, so you don't want to leave it out in the rain. But the other end of the cable, I literally just clipped the end of the cable off and I crimped on power poles so I could then just plug it straight into my Power Mini and boom, it's ready to go. So if I was going to operate this setup here, I would literally just take my Biono battery, plug it into the solar charge controller, and notice it powers up the solar charge controller right away, and it's ready to go. And then I could take the solar panel, if I had it running, had it all opened up, and just plug that in, and it would start instantly charging and be ready to plug my radio over into the other side of the load for that. So, and that's how long it takes to get your solar station up and running for these. A couple of other questions we have there.
Well, Dan's got his hand up. So Mr. Lodi, Dan, take it away again.
Yeah, so this is a humbling thought that I've had that I need to share with everybody who's interested in emergency communications and wants to buy American. And the situation's getting better, and it's been brought under scrutiny because of the supply chain issues of the pandemic. But everybody look around you and try to identify everything that wouldn't work if the electronic chips and circuits that were made in China suddenly disappeared. And all I'm saying is that as amateurs, we should encourage STEM however we can, because otherwise that will be our future one day when we don't make anything we rely on in this country in terms of electronic components that are made by the hundreds of thousands, if not millions. And that goes to, everybody's beloved iPhones and other kinds of phones and all the nifty gizmos we have. We need to get back to where we have that production capability in the good old US of A.
And I probably went too far, so I apologize. I see Don had just made thank you. I see Don made a quick note here in the chat also. He says the ability to provide a community solar USB cell phone charging kiosk, although it's not comms, it's a great service that's to be able to offer to your served agencies. And that is definitely something to really consider when we're showing up and we're supporting our served agencies. We're supporting them with whatever it is that they need. Sometimes it may be doing something like providing some charging capabilities for your own individual operator needs. Things like, if I switch back over to here, things like the Power Mini, and a lot of the solar charge controllers will have a USB port directly on them so that you can charge your cell phone or what have you. If you're doing WinLink comms, we love to use radios, but you want to use the most effective communications that you have to get the message through as quickly as possible. So for those of us in emergency communications that are maybe using FirstNet, where we've got cell connections still in the region, and we can use those data connections, being able to do things like send your WinLink traffic via Telnet directly using your radio and be able to keep your cell phone powered up for that amount of time can be a really key. And in fact, the Biono, those little panels that I have, let me see if I can get them out real quick. These, the 28 watt ones, these guys here, I open those up. On the back side of them is where the charge controllers are, or the built-in power management system is. And there's actually a USB port right on the panel. So let me move my head out of the way so you can actually see it. Sorry about that. Right on the back of those panels, there is a USB port right on the panel, so you can plug your device in and charge it. And there you go. That's what those look like, and they fold out into four. Actually, let me zoom back out a little wider for the camera so you can see what that looks like. There you go. So these are those panels. They're actually generating charge right here in the booth right now, and there's that USB port. So great point there. I saw that go by in the chat. Doug, you have a question also. What you got for me?
Another comment. You mentioned clipping the end off of that cable and putting your power poles on it. I do the same thing, but I go back up about a foot on the cable and clip it and put 2 power poles in it, and then I've got the original termination if I have to use it somewhere else.
Absolutely. So I may not have been clear with doing that. So for something like my ICOM 7300, it's got that custom power connector that's on the back of that. So I come off of that, I clip the cable off, put power poles on it. You could go just past where that is, where they have the inline fuses already. You could leave that all as one unit. That way you always know it's always there. I swap my inline fuses between different radios sometimes. So that's why I clip that part off to be able to switch it around. Radios where the power leads come directly out of the radio, pull out what's the right amount for your radio. That seems, you always want to do shorter distances if you can. And then you have a little more flexibility as to how you're wiring up your system.
Okay, very good comments. This has been very educational. I appreciate this, everybody, Chris, and the people asking the questions. Okay, well, we're going way over, but this is okay. It's been a good presentation. Are there any more questions? I don't see anything in the chat. Do you, Chris?
Just trying to catch up in the chat. Solar panels creating current from info rights is renewable energy at its best. Yeah, it is renewable energy at its best. Bruce, I see Bruce has her hand up. Bruce's iPhone.
Yeah, sorry, I had to watch this on my iPhone. So my question is, can you send the copy of the chat log when you send the recap message? Usually you guys send a link and all that, but I'd like the chat log in this one, please.
Yeah, I do. I almost always do. It's part of it going out. So all the links are in there. And also, Chris, while I'm thinking about it, I'd like to ask you to send us a copy of your presentation, your PowerPoints, if that's what you use, so we can post that as well.
Okay, I'll actually have that up on Wave Talkers, and I can send you what the link to that is, so you can get to it.
Can I download it?
You'll be able to watch it up there. I don't usually put up my slides so that they go out, because there's lots of moving pieces in all the slides. They don't usually show as one.
We'll work around it.
Yeah,
okay.
We can work on something for that.
Made it back.
Well, hi, Barry. Barry had a power failure, and so he decided to take a vacation in
Oh,
Florida.
hey, Barry.
Okay, I think we're about ready to wrap this up. Unless anybody else has got anything else they want to add, subtract, or multiply here. Not seeing anything. Again, thank you, Chris. Thank you, everybody. It's been a great presentation.
Thank you very much. Thank you for having me.
Thank you a lot. Thank everybody for coming. This was interesting.
Thanks, everyone.